Alright, so this here is Dan. Um, well, that's Dan. That's just me drawing Dan. And essentially, he is on a wooden block, right? That's around his height. And that wooden block is on two weights. Weight one, weight two. And then we calculated that this scale read 93 pounds, and this one read 79 pounds. Without Dan, it read 10 pounds and 9 pounds. Okay, so if we're trying to find the center of mass, we already know we just need to set up a little torque model. Um, this is gonna push down this way, right? Like the force, and the force here would be like that. So where will we put our pivot? We do know that the center of mass would push back up, right? It's gonna counteract those forces. That's why there's no movement, because those forces are the equal and opposite to that force. Okay, and we would put the pivot here. That way, the unknown stays here, known stays here. You guys know this. Come on, this is easy stuff. Torque clockwise equals torque counterclockwise. We are missing the measurements, don't we? Don't we? Like the distance, right? So if our pivot is here, we actually measured this, and we got 134, and here it was 66. All right, let's plug and chug, right? Torque clockwise, those forces gonna go clockwise, so they go here. Um, but before we start, what should we do with those two things? This is both of them combined. This is both of them combined. This is just the weight of the block of the wooden slab that he's standing. Because we don't care about the wood, we subtract it. That way, it's just down there. And we use the wooden block just so it's as horizontal as possible to the floor to prevent any unnecessary, like, you know, difficulties and stuff. So here we know torque obviously is force perpendicular times distance. So here we would have 83 pounds times the distance 134 centimeters plus 70 pounds times 66 centimeters, and that would equal our Dan's weight, and we figured out that it should be around 153 pounds. Right? Yep, 153 pounds times the distance, which would be our center of mass. So notice how we keep pounds and centimeters, because once we solve all of this, let me whip out my calculator. I got for D 102.9 centimeters. And notice how the pounds cancels out. We just have centimeters, and that's why we don't care about the units as long as they're the same. So what does this mean, right? Um, well, all this is saying is from the pivot, if we go this way, 102 centimeters. That's where the center of mass should be, so like somewhere there. So let's see. Let's make that a percentage so we could understand it better. So that is our center of mass from the block, not Dan. Well, actually, it is Dan. Remember, we subtracted the block's weight, the wooden block's weight, and this is Dan's height. So when we divide that, we get 58.1%. So that means from his feet, if we go up 58%, up his body, that's where his center of mass is. So like somewhere here. So Dan's a big boy in the upper area more than he is in his lower area. So Dan, you should start doing squats. All right.